Good morning, everyone. I don't need my glasses to read. Thank you for participating in the third biannual Virox Cleaning, Disinfection, Sterilization Symposium. I'm Nicole Kenny from Virox Technologies. With a number of media accounts just this past year pertaining to lapses in cleaning disinfection practices, both the environment and medical devices that resulted in either outbreaks or healthcare facilities having to notify patients for their potential exposure of bloodborne pathogens, the role of cleaning, disinfection, and sterilization, I think, has never been more important. And on behalf of my co-chair, Darlene Meads-Montero, and myself, we hope that you're going to enjoy the list of today's topics and the speakers that we've put together, and that you'll find the symposium as interesting as we did in terms of organizing it. Just for everyone, if you haven't situated yourselves, the washrooms are just out to our left. We don't really have any other housekeeping items this morning. I know that lunch is going to be an iterative lunch, but we'll talk about that a little bit later. It gives me great pleasure to introduce Dr. Syed Sattar, someone who I consider a friend, has always been willing to provide insight and answers to questions that I have, and can, in the nicest of ways, let you know when your thought is not scientifically sound. It happens a little bit. Dr. Sattar is the Professor Emeritus of Microbiology and also the founding director for the University of Ottawa Centre for Research of Environmental Microbiology, CREM. He studies the environmental fate of microbes harmful to humans. Another focus of his work is evaluating and promoting safer and better means of preventing environmental spread of microbes. Microbicide test methods developed by him now form the basis for several national and international standards. He has published over 225 peer-reviewed papers. I've read a few. He's had several chapters in conference proceedings and books, and he's delivered over 325 lectures worldwide, and he's the co-editor of the 5th edition of the reference text on the principles and practice of disinfection, preservation, and sterilization that was published last year. We consider that, from a disinfection perspective, our Bible, if you will. Dr. Sattar is a registered microbiologist of the Canadian College of Microbiologists. He's a fellow of the American Academy of Microbiology and a fellow of the Academy of Hygiene Scientists. He is a member of the editorial boards of the American Journal of Infection Control and the International Journal of Infection Control. He's the advisor to Canadian and US governments, as well as the World Health Organization, the Organization for Economic Cooperation and Development, and the International Civil Aviation Organization. So I'm assuming that means we're going to be able to fly safer and less transmission. He's a recipient of numerous international awards and fellowships, and more recent among these being the Martin S. Favero Lectureship, the OCRI Award, the Hygiea Medal of Rudolf Schulke Foundation. And in December of 2012, he received the Queen Elizabeth Diamond Jubilee Medal for his community and professional services. Earlier this year, the Canadian College of Microbiologists recognized him as a distinguished microbiologist for his long-standing services to the field nationally and internationally. Before we welcome Dr. Sattar to the podium to give his talk on decontamination of high-touch surfaces, how crucial is wiping and reducing pathogen load, I would like to add one additional item to his long and distinguished list of awards and honors. Dr. Sattar, in recognition of your highly notable scientific career of nearly 5 decades, we at Virox Technologies, along with your friends and colleagues in the Canadian infection prevention control community, are honored to publicly recognize your commitment to excellence. We are pleased to announce the creation of the Syed A. Sattar African Scholarship. This award will enable deserving recipients from an African country who wouldn't ordinarily be able to afford travel for educational purposes to attend the national conference of the Infection Control Africa Network. In addition, we're delighted that we're sponsoring your attendance to the 2014 ICAN conference in Zimbabwe, where you will also be honored by those who your work has had immeasurable impact. Thank you, Dr. Sattar, for your lifetime dedication, improving lives, and bettering our health.
Good morning, everybody. It is wonderful to see the room nearly full so early in the morning. I hope you will enjoy the presentation and the ones that are to come later. Somebody once defined a lecture as an experience which makes you feel dumb at one end and numb at the other. Now, I can tell you that you don't need to feel dumb in the sense that you're free to ask questions. If there is something which is a burning issue, you can interrupt me, but preferably, of course, we would have time for a question-answer period later. What you do about the numb end, it's up to you to decide. Okay, so the topic is something that I have been talking about quite frequently in the last 2 years or so. So some of you may have heard me make these points, but still I believe that they are worth repeating because I have become more and more convinced over the last few years that environmental surface disinfection is something that has been slipping through the cracks, and that there are so many gaps and so much misunderstanding about this whole issue that we seem to be kind of missing out on how to do it properly. Now, at the same time, normally, if you have heard me speak, I don't overload my slides with a lot of figures and charts and graphs and so on, because in a situation such as this, people just don't have the time to be able to absorb those when they're sitting in the audience. So I'm going to focus on general remarks to give you more of a bird's eye view of this topic. But of course, I am available, and we have published papers with greater details on this particular aspect for you to refer to. So, in the spirit of full disclosure, as you can see here, I receive research funding from both private and public sources, and over these 40 years of work, I have managed to receive funding to the order of about $23 million, which is, I would consider, fairly respectable. But it carries with it a certain responsibility as well, because nobody gives you money and not expect things to come out of that funding, a grant or whatever. So it's a responsibility that one has to carry. And I'm a consultant to certain companies, but I'm very picky about what companies I choose to deal with. I can tell you stories about how I have had to wiggle my way out of certain companies that had essentially written me or wanted to write me a blank check, and I said, no, thank you very much. My soul is not for sale yet. And then I also regularly interact with a lot of organizations, such as the World Health Organization, and Nicole just mentioned that. So the list is long, so let me not waste your time in going over it. I'm also a member of the board of directors of Virox Technologies, and so that is something that everybody should be aware of. And I will refrain from mentioning any specific products or services, and if I do mention it, it will be for information purposes only, and no endorsement is meant from my side or from my university or my center. So what is the issue that we are grappling with at the moment? There is mounting recognition of the fact that environmental surfaces play a very crucial role in terms of the spread of a variety of pathogens in healthcare settings in particular. There was a time some 40 years ago, this was not regarded as important enough to receive any kind of attention, but the tables have turned. Even the most sophisticated, most influential standard-setting organizations and those that are led by thought leaders have now come to recognize that environmental surfaces do play a role. But why has this change occurred? That's a very, very crucial question. And the way I explain it is, if you're looking at a dark black background, which has gray spots on it, of course you don't see the gray spots. But as the background gets lighter and lighter, those gray spots become more apparent. And so over these few decades, we have cleaned up a lot of things which were that black, dark background. And as a result, we are now seeing things which were hidden, and now they require attention if we need to continue to improve our efforts at infection prevention and control. So this is the philosophy that one comes from, and that there are lots and lots of papers. And at the very end of this presentation, I have a reading list where I have chosen a couple of those presentations which are very well written and document this point extremely well in a fairly solid scientific basis. So the role of environmental surfaces in the spread of infections, particularly the high-touch surfaces, it's certainly not something that you can ignore any longer. As a result of excuse me, this awareness, there is also a corresponding increase in the technology to be able to counter the role of environmental surfaces in the spread of infections. Now, when, when this happens, there is always the good and the bad and the ugly that comes with it. So some companies are more ethical than others. They will make sure that their products and claims are scientifically based and that they are realistic, but others will make all kinds of claims without much supportive evidence. So therefore, one needs to be very careful, judicious, judgmental in being able to sift through what might be valid and what might not be. So again, my purpose today is to give you more or less a critical outlook of what one should be looking for in general terms. Because when you talk about high-touch environmental surfaces, I can tell you that if I asked every one of you here, you will come up with a slightly different list, and there could be major disagreements as to why things should be there on that list or should not be there on that list. So again, in terms of generalities, there are certain criteria that one should look at in being able to decide as to what are the surfaces that need more of an attention. So here is what I would like to propose, in that there are surfaces which certainly may become contaminated with pathogens, but they may not have the capacity to donate pathogens as readily as some of the other surfaces. So then there are some surfaces which do not allow pathogens to survive well on them. And that is an extremely crucial point. I don't have time to go into the details here, but I have data on certain very important and very common healthcare-associated pathogens, such as Staphylococcus aureus, norovirus, Clostridium difficile, and how those important pathogens survive on high-touch environmental surfaces. And you'll be surprised in terms of their durability, depending on the type of pathogen we are talking about. Take the example of Clostridium difficile. Our work has shown that the decay rate in terms of the viability of the spores under ambient conditions indoors is something like 0.1 log per month, which is extremely slow. And this is why when we're dealing with a spore-forming bacterium such as Clostridium, one has to be very, very careful about not only understanding its survivability, but also in being able to deal with the hardy nature of the spores. The same thing applies to noroviruses, Staphylococcus aureus, VRE, and Acinetobacter baumannii, and so on. So the list goes on and on and on. So the pathogen, or any kind of pathogen, needs to survive on those surfaces, and it also must be available for release on casual contact. Now, this particular point, again, is based on a lot of our own work where we have systematically studied this release of pathogens on casual contact. We have done this with different kinds of moisture levels, different kinds of pressure that you apply during this contact, and I can tell you that on very light touch with some of these surfaces, as much as 20% of the infectious agent is readily transferred to human hands. Then human hands become the secondary vehicles for the spread of those pathogens in many healthcare settings. So the survival of a pathogen on a high-touch surface is something different than the release of pathogen or its capacity to donate pathogens to hands on casual contact, well then amplifies the potential for the transfer. And then the location and frequency of contact is something else. So again, you can decide as to what might be a surface in a hospital ward, for example, which is more likely to be touched, more likely to release the pathogen for its eventual spread. And then the contact or the frequency contact with mucous membranes for entry into the body of a susceptible host. If that does not happen, when you invoke a scenario that even though an environmental surface is touched, it is able to release pathogens onto hands, but if hand hygiene is practiced the way it should be, then you're putting in another barrier in the spread of that pathogen to a susceptible host. So all these factors need to be considered together. So the other question is, what pathogens should we focus on? Because the list is long, and some pathogens are, of course, more horrible than others. But what one has to remember here is that the severity of an infection caused by a given pathogen isn't necessarily the need for the focus on it. For example, and I'll just make these points so that they're there in front of you, is that certain very important pathogens simply do not survive well on environmental surfaces under ambient conditions, one thing. And even if they do, the potential for their spread through those contaminated surfaces is much lower than that of certain other kinds of pathogens. One thing that we run into quite often is that the label claims on disinfectants or even on disinfectant-soaked wipes have no relevance to the potential of a given pathogen to spread through high-touch environmental surfaces. The list is long, but I just will want to sound out 2 or 3 of those that you're well familiar with. Influenza virus, SARS, HIV, and so on and so on. Those pathogens, they're all enveloped viruses. They generally do not survive as well on environmental surfaces under ambient conditions, nor is there valid scientific evidence that they spread through such vehicles in a hospital, for example. So what this amounts to is claims based on essentially a fear factor. And I blame infection control practitioners or infection preventionists in this context because people who should know better tend to ask a company representative, say, well, your product doesn't claim activity against the SARS virus, for example. And of course, a very diligent company representative will rush off to his managers and say, my customers are asking for claims against the SARS virus. Can we do something about it? So the next thing is that that company contracts out to some laboratory to do the testing, and the next thing you know is that there is a claim against the SARS virus. Now, luckily, and if I may say so, through our education of regulators, that practice is now much less common in Canada. But in the United States, still, you will see long lists of pathogens which have absolutely no relevance to their propensity or potential to spread through environmental surfaces. So that judgment has got to be made, and this practice has to be put to rest before we cause too much confusion and unnecessary burden on the testing of the products. So a pathogen has got to be able to stay viable on a given surface and be able to be released. And when you ask companies to come up with label claims that are irrelevant, what you're doing indirectly is to create safety problems for those contract labs that is their business to test products against these pathogens. And again, I have known contract labs which have been requested to test environmental surface disinfectants against rabies virus, for example. Why? I don't understand. And if one wants to work with rabies virus, of course there are some vaccine strains available, but the hot rabies virus is extremely dangerous, and you can only work with it under a BSL-4, a Biosafety Containment Level 4 facility. So it's a bit of a contradiction there. So the focus has to be on the potential, and I will show you a table later on as to what I consider to be the most likely candidates for testing, so that you'll be able to complete the entire gamut of those pathogens that might spread through contaminated environmental surfaces. Now, this particular diagram, which came from a recent article in the Scientific American, calls high-touch environmental surfaces as hotspots. It doesn't matter. The terminology still refers to those surfaces in a hospital ward which are touched very frequently. Now, such surfaces exist not only in a hospital ward, but other places in a healthcare system. To give it perhaps a bit more quantitative understanding, Dr. Rutala's group published a paper some time ago where they had people observe the interaction of healthcare workers with environmental surfaces. And on the basis of that, they have come up with a list that is there as you can see on your slide. As I said, this is a pretty good list to work from. You may want to add other things to it based on your experience, but then that is not the purpose for us to exhaustively come up with an exhaustive list at this stage. Now, if you're wiping environmental surfaces, there are certain pros and cons. No technique or no process is completely perfect. And somebody once said, perfect is the enemy of good. So if you want to do a job properly, you should be able to understand the objectives, but try to reach perfection. Perfection, of course, is kind of counterproductive. But if you look at the pros, there are enough to be able to justify the proper wiping of environmental surfaces to reduce the pathogen load. From a workplace safety point of view, the release of potentially harmful chemicals into the air is one thing that is minimized. I'm not saying that it's completely eliminated, minimized. And there again, you're creating a better, safer workplace. The other thing that it does is to reduce the amount of disinfecting chemicals that you are using within a workplace setting. Therefore, you're also reducing the loading of the environment with such potentially harmful chemicals. So there are these advantages, and one of the major ones is that by wiping, you're combining the disinfecting action of the chemical or the formula that is there on your wipe with the mechanical action of removal of that particular pathogen that you're trying to get rid of. This, in fact, raises the prospects of being able to reduce the level of contamination or to a much higher level. And I will show you some figures to be able to illustrate this point a little bit more. As always, there are certain negative aspects to wiping, which you can actually minimize by understanding the type of product you're using. In this case, you need to understand that if you're wiping a surface with a weak disinfectant soaked into it, you are in fact being counterproductive in the sense that a localized area of contamination during wiping with a weak disinfectant results in a wider spread of that contamination in that particular setting. And this is certainly counterproductive because you may in fact be increasing the risk of spread of that particular pathogen in that location through the process of wiping. Now, is this a big issue? I submit to you it is, because a certain hospital, which shall stay without being named, in a developed country has been using, believe it or not, grapefruit extract to wipe surfaces in an intensive care unit while dealing with an outbreak of Clostridium difficile. Okay? So people who have actually pursued this have been able to show that in the process, they were of course not killing the spores of Clostridium difficile because grapefruit extract is not strong enough to be sporocidal, but in the process they were actually spreading the spores over a much wider area, being counterproductive in a sense. So there are these real-life illustrations where such slip-ups can occur. So one has to be very careful about this. And then the other factor to remember is that the contact time between your wipe and the surface is extremely short. It's a matter of seconds. And I will show you through a couple of graphs that if you're doing the wiping properly with the right kind of wipes, you need only a contact time of a few seconds, no longer, to be able to achieve high levels of reduction. And in the case of the wipes, certainly it'll add to the cost factor because by the time these things are tested, approved, packaged, and supplied to you, they are certainly more expensive than using a liquid disinfectant in being able to wipe surfaces by taking a rag and doing it in your particular setting. There are certain disadvantages of being able to do that because the variability is much, much greater in that context. Yet another point before I go on to the next slide is that wipes themselves actually add to the solid waste stream because the more wipes you use, the bigger is the garbage that you produce. And this is why regulatory agencies such as the United States Environmental Protection Agency are promoting the idea that companies should be using the wipes which are biodegradable or compostable so that again you can get rid of that waste without it adding to the amounts of or the piles of garbage that we are already dealing with. So that technology is still to be developed. Manufacturers have actually taken on that challenge and are beginning to address that issue. One last thing here is that when you have a disinfectant being soaked into a wipe, depending on the type of wipe material, the disinfectant's active can become neutralized or bound to the fabrics of that particular wipe, meaning that it is no longer available to do the job of disinfecting that surface that you're wiping. This factor is often not taken into consideration. If you take a cotton-based fabric and add a quaternary ammonium-based formula to it, you will see that there is rapidly a reduction in the available amounts of quaternary ammoniums on that particular fabric. So to be able to make proper label claims, one has to be able to look at that particular point. So, when we are expected to wipe high-touch contact surfaces, I submit to you that the housekeeping staff are not properly trained and are not properly monitored. Therefore, the job is being done in a half-baked manner. The work of Dr. Phil Carling, whom I'm quite sure you all know, has proven this without any doubt, using the fluorescent markers that oftentimes surfaces that need to be wiped for decontamination are not properly wiped. So again, we are living in a false sense of security. So as I said earlier on, cursory wiping is probably worse than not wiping at all because you are being counterproductive in terms of spreading pathogens over a wider area. And I made this point already about the wipe itself having a demand. So when you do test the wiping, the contact time has to be no longer than a few seconds because that is what is happening in a field situation. The amount of liquid that you deposit on the surface also cannot be very large because in our own studies we have shown that in such wiping, the amount of liquid deposited on a unit surface area from a pre-soaked wipe can be a fraction of a microliter, which is an extremely small amount. Of course, that small amount evaporates very rapidly, so it has to do the job in a very, very quick fashion. And unfortunately, at the moment, methodology or standard methods to be able to assess wipes for their ability to decontaminate environmental surfaces is weak or flawed or simply doesn't exist. But if you look at this simple diagram, you will agree that in the vast majority of cases, one ends up by wiping the surface for decontamination. There are minor variations in the theme, but the basic theme is that wiping is extremely widespread and crucial for decontamination. So this is something that is based on a lot of observations. This comes from a recent publication that I and Dr. Jean-Yves Maillard put together to show you that wipe technology, again, isn't that simple magical process. A lot of thought has to go behind it to be able to come up with the proper testing protocol to develop a really valid product for use in healthcare settings, for example. So this gives you all the various factors that together impact on the effectiveness of decontamination by wiping. Available tests are, as I said, either flawed or they simply don't exist. The ones that are available are semi-quantitative at best, and we have actually looked at each one of these to be able to take corrective action, which I will talk about in a moment. There are a couple of international standards, but there again, they are semi-quantitative and not very reproducible. So to try and address this issue, we have come up with this device called the Vibrator, for want of a better word. So this was my brainchild, and I sat together with a Dr. Tony Sharp, who is a PhD microbiologist and a mechanical engineer. He's a genius, as far as I can tell. And he, in fact, went home and came up with this device that meets perfectly as to our requirements, because this device can wipe a surface under predetermined contact time, the number of strokes, the pressure between the surface and the wipe itself, and so on and so on. And we have now put it through the steps, and we have just completed an international collaborative, the results of which will be published pretty soon. But just to give you an inkling of what the Vibrator has been able to do, I'll present to you these two very simple graphs. You will see that from this particular one, this was the level of contamination, the baseline. So here you can see that the level was almost 1 million organisms on a small metal disc for wiping. And when we tested 4 different commercially available wipes, one of them, in fact, removed or killed all those 1 million organisms and made it completely undetectable right here. But then the 3 other commercially available wipes reduced the contamination, but were not able to completely make it undetectable. So if you take the wipe that has just been used to wipe a contaminated surface and touch it to a clean surface, does it have the potential to transfer contamination to a clean surface? And here you can see that the ones that were unable to remove the contamination, in fact, very successfully transfer the contamination to a clean surface. Again, reinforcing the scenario that a weak disinfectant can, in fact, spread contamination during the process of wiping. So if you then look at, these are data with Staph aureus, and the wiping was done only for 5 seconds. 5 seconds. This is very, very crucial. What happens if you do the same thing with another important nosocomial pathogen, Acinetobacter baumannii? It proved to be a little more sensitive in the sense that 3 out of the 4 wipes that we tested reduced the contamination during wiping to undetectable levels. One of them was not that successful, and when you contacted this wipe to a clean surface, of course, it also managed to transfer the contamination to that clean surface. Again, in this case, Acinetobacter baumannii, wiping was done for 5 seconds only. We now have a lot more data which will be published pretty soon with different kinds of scenarios and in the presence of a soil load, in the absence of a soil load, and so on and so on. So I'd suggest that you wait to see more of that in a peer-reviewed journal. And this is the collaborative that I'm talking about, where we were able to test a number of other types of commercially available wipes to be able to prove the same thing. Here is what I suggest is a list of potential surrogates to represent all the major classes of human pathogens that you might come across: Staph aureus, the gram-positive coccus, and Acinetobacter baumannii. I like to really promote the use of Acinetobacter baumannii because not only is it an emerging pathogen, but it's also one that is naturally more resistant to antibiotics and disinfectants. And environmental surfaces do play a role in its spread. So it survives much better on your surfaces that you want to test, as opposed to E. coli, for example, or Klebsiella pneumoniae, which are often recommended as surrogates for gram-negative. So the rest of the table is something that I'm sure you're familiar with. The other thing that we are trying to promote the use of is the feline Kalichi virus. It's a wonderful virus to work with in the sense that it's easy to work with, it gives you results faster than most other viruses. It is also safe for humans, and it is also naturally more resistant to a variety of disinfectants and antiseptics and so on. So you might see data being published soon with some or all of these pathogens. So where should we be going in the future? Again, I like to suggest that we need to discourage this practice of using the bug of the month to create what I would consider as a fear factor, which is totally unjustified. We need to incorporate proper surrogates in the wiping protocols for the label claims to be meaningful. We need to test microbicides, environmental surface disinfectants, with the wiping action incorporated, and that is not done often enough because they are mostly used for wiping of high-touch environmental surfaces. And we need to use or focus on safer and better chemicals or disinfectants for wiping, and this has been a long-standing message that I've been promoting, and hopefully it is actually making some sort of an impact. And we need to promote the harmonization of test methodology so that it becomes more economical for companies to say that, well, I have used a method, the results of which are acceptable to Health Canada, to US EPA, or in fact regulators in European countries or Australia or Japan or whatever. Otherwise, it becomes, product development becomes too expensive for companies to venture into such an exercise. We must train and monitor our housekeepers better. I believe we are going to hear more about this topic a little later on, but I can give you many examples from my own experience dealing with healthcare facilities that is still not done to the level at which it should be, because we are expecting housekeepers to perform this crucial job, but without providing them with the necessary tools or the necessary skills to be able to do that. And this is where I think we are missing the boat. Here is the list of publications that you may want to pursue, and I thank you for being patient. There are people that are listed here that I do want to thank. Thank you very much.
That was an excellent presentation. We do have time for a couple of questions. If I can perhaps start off. The Vibrator test you're doing, I'm assuming you've tested just one type of wipe substrate. Does it have the ability to test microfibers, cotton, cloths, everything, to see whether there's, as you talked about the interaction with cotton and quats, is there the ability to then use that to determine how other wipes, substrates might interact with disinfectants?
A good question, Nicole. Yes, we have tested wipes based on different kinds of materials, and we can also show the transfer of pathogens from a wipe of a hard, non-porous surface to human hands as well. So this particular device is capable of testing not only inanimate surfaces, but also animate surfaces in the form of human hands.
Thank you. Michelle, there is a microphone back there, just so everybody can hear, please.
If I'd known I had to get up, I probably wouldn't have asked the question. Sad statement on human nature. Syed, could you comment, in the PIDAC document, there's actually a statement in there regarding the fact that disposable wipes should not be used for disinfecting or cleaning environmental surfaces. From your data, could you maybe comment on what you think about the value or lack of therein of wipes being used for disinfecting environmental surfaces?
What we have found is that if you take a rag of any kind and then soak it within your facility to be able to do that, there is potential for wide variations in the effectiveness of that particular rag in decontaminating surfaces. So if you're dealing with pre-soaked wipes, the part of product development entails not only to look at the compatibility of your actives with the fabric itself, but also the volumes that are necessary to be able to keep and deliver the right kind of or liquid onto the surface and so on. So there are advantages. I'm not suggesting that you cannot really take a piece of fabric at your old setting and wet it, but you need to be worried about quality control a bit more.
Wonderful. Thank you, Dr. Sattar, and congratulations again with your response.
This is truly a pleasant surprise, and I'm truly honored. Thank you, everybody.